A clay layer of thickness H has a preconsolidation pressure Pc and an initial void ratio E0. The initial effective overburden stress at the mid height of the layer is P0. At the same location, the increment in effective stress due to applied external load is delta P. The compression and swelling indices of the clay are Cc and Cs respectively. If P naught pre-consolidation pressure is less than the PC, sorry, P naught is the initial overburden pressure which is less than the pre-consolidation pressure which is less than the current stress. Current means the initial plus the extra pressure which is coming. Then the correct expression uh, to estimate the consolidation settlement SC of the clay layer is. Okay. See, first of all, to talk about consolidation, see, let us change the color. When, if you see, if you draw a graph between void ratio versus log sigma. Sigma is effective stress, effective vertical stress. So if you draw graph between them, you will get a straight line, negatively sloped straight line, because you are taking in terms of log, semi-log graph this is. Okay. If you take the slope of that graph, okay, this is slope is Cc. Cc is E1 minus E2 log, okay, suppose this is E1, this is E2, E1, okay, then sigma 1, this is sigma 2, okay, sigma 2 is more here, okay. Then we are talking about absolute values, so you can say that log sigma 2 by log sigma 1, okay. Sigma 1 here is initial, okay. Sigma 2 minus sigma 1 is the delta sigma. This is the extra pressure change in change in pressure or stress, okay. Then how can you write this? And E1 minus E2 is nothing but delta sigma divided by, I can write sigma initial plus that extra change in pressure divided by sigma initial. This is the slope of that graph. Oh, I didn't explain about this graph. It is because it is very obvious. See, when the stress is increasing on the soil, compressive stress, of course, the void volume will decrease. Then void ratio will decrease. So it's inversely proportional, because when the effective stress is increased, the voids will become reduced because it is compressed. So that's clear. So this slope of this line is nothing but, okay, it's called as coefficient of compression index. Coefficient of compression index. Okay. Now from this I can write delta sigma as Cc multiplied by log sigma initial plus that change in stress divided by initial. So this is the delta sigma. Okay. Now what did we understand? So this here uh, I'll tell you one more thing, that so whenever you want to calculate settlement delta H or settlement, it's nothing but H multiplied by change in void ratio divided by 1 plus E naught, initial void ratio. This you can derive from any like from the concept, it is available. It's just that delta H by sorry, H is nothing but delta V, because one dimensional consolidation, okay. delta V equal to delta E by 1 plus E. So this is according to the concept you will get delta H settlement is nothing but this. So now why we can write settlement is H multiplied by Cc log sigma initial plus change in effective stress sigma initial divided by 1 plus E naught. H by 1 plus in place of delta C, E, I just wrote this. Now, this settlement is valid. This settlement formula is valid for this kind of for this line because the settlement how I calculated settlement of due to what due to this much change in stress. This much change in stress has caused this much settlement. Okay, this much change in stress is varying from sigma 1 to sigma 2, sigma 1 to sigma 2, which is actually causing to change sigma E1 to E2. So if you see this sigma 1 and sigma 2, it is in between a continuous straight line, and also this is called normally consolidated line. Okay, NCL, it is only single line, which is a straight single line. In that case, I have taken the I have taken the slope CC of that line. I have taken the slope of that line multiplied by log of initial stress plus the final stress by initial stress on that end points of that line. Okay, so that is how the formula is developed. But there is in this question, if you see pre-consolidation pressure is there for that soil. Currently is the currently it is overburden stress is P naught, but in the past it has been subjected to this much pressure, but that was released later, and now it is P naught only. So P naught is less than the PC. Because of that, you can say this is over consolidation. So in the over consolidation, how what will happen? So if you see E and sigma, so first it is this is NCL line, right? As the effective stress is increasing, the void ratio will decrease on a straight line. Okay, log sigma on a straight line. But after reaching some point, any point, if you reload it, reload means you are removing the stress. If you are removing the stress, what happens? It will again rebound. Okay, it will swell. Now, currently, suppose this was starting, then it has gone up to here. Okay, after coming here, then again you are removing the load. Okay, if you are removing the load, it should go in this line. You think like that, but it's not right because there is some elastic settlement and there is some plastic settlement. Settlement will not rebound. Only elastic settlement, elastic compression, or elastic change in void ratio will change, and that will go back to here. It is it will swell. That's why this portion is called swelling portion. And okay, now you are at this point. Let us say this is P naught, right? That is P naught. Okay, but initially it has been subjected to this much, that is PC. This is pre-consolidation. So now, for at this time, but in the present you are at this point. Okay, when you load it again, what happens? It will follow this line. Okay, this is nothing but swelling as well as recompression. Swelling as well as recompression. See, in the last slide I explained the slope of this line is CC, coefficient of compression index. But if you take the slope of this line, if you take the slope of this line, it may be swelling compression index or recompression index, recompression or swelling index, like that. Okay. So now slope of this portion is CS or CR. So from here to here, it will follow that path. After that, if you increase the load, then it will follow this. Okay. And this is nothing but again CC. Okay. Now here in the question you are saying that you are at this point finally. Okay, you see that. See, initially this much overburden present at the same location. The increment in effective stress due to applied external load is delta P. You are increasing with delta by delta P. That means P naught plus delta P. But here it is said that P naught plus delta P is more than PC, more than PC, somewhere here. Delta P plus P naught. Okay, finally is this much. Now, if I want to calculate the settlement, if I want to calculate the settlement from here to here, so what did we write in the last slide? H by 1 plus E naught CC, this completely corresponding to delta sigma. Okay, this completely corresponding to delta sigma. Okay, what I'll write? H delta sigma by 1 plus E naught. Right. But the delta sigma from here to here, one variation of delta sigma, right? This is let us say delta sigma 1 from here to here, delta sigma 2, right? There are two delta sigmas. Fine. What will I do? Delta sigma 1 divided by 1 plus E naught. Total sigma, okay, delta E2. Sorry, H by 1 plus E naught multiplied by total delta E naught. Total delta E is nothing but delta E1 plus delta E2. So now how can I write H by 1 plus E naught? Okay, but delta E1, delta E1 is from here. So how to write that? It is CS multiplied by, okay, it's nothing but you are talking about y coordinate. Y coordinate is nothing but here slope, slope multiplied by x coordinate. Slope is CS multiplied by x coordinate is how much? X coordinate is the change here. Y coordinate is this, x coordinate is this. Okay, x distance. X distance is how much? So log PC by P naught. Log PC by P naught. Okay, that is delta sigma 1. What about delta sigma 2? Delta sigma 2 is from here to here. Okay, you have to find out delta sigma 2. If you know the y, you can find out x just by multiplying the slope. Slope is here CC. What is the x coordinate here? Log delta p plus p naught by pc, right? Delta log delta p plus p naught by pc. Okay, this is the totally delta sig E1 delta E2. That's it. If you see the graph, if you see this, you will understand. So wherever you find this, that is the option. So this is everywhere, this is correct, this portion. Then initially CC, but PC by P naught, this is wrong. Okay, CS PC by P, it is right. Okay, CC P naught by, this is also right. So option is this, but still I want to check other things. CC P naught by PC dash, this is wrong. This is in reverse actually. CS, it is reverse. PC should be above. Okay, this is also wrong. So the option is B. Thank you.